Hi guys, this is Miss Regine from Soar Educational Services, and we are here to practice some more pre-calculus questions to prepare for the AP exam. So in this particular question, you are asked to find the end behavior of the graph. So what we have here is we have in the highest degree is odd, and it's a negative graph. So you can quickly draw a rough graph of this. So with an odd degree, they're opposite. So if right side goes up, left side goes down. But in this case, it's also negative. So what I know is going to be happening here is the right side is going to be going down and the left side is going up. Because that's what a negative does. The negative right side goes down, left side goes up. And the fact that it's odd degree means that they do go in different directions. Okay, so now we have that. We don't really know what's going on in the middle. There might be 5 real zeros, and I don't know if I even counted 5 here. Let's see, 1, 2, 3, 4, 5. Yeah, I did way more than 5, but that's not important. So what's going on in the middle is not so important. But just for our end behavior, what you need to realize is that, okay, if I'm just looking as x goes to negative infinity, so that means on the left side of the graph, let's just do that as x goes, let me try something that works better. As x goes to negative infinity, what we see, p of x is going to positive infinity. And as x goes to positive infinity, p of x is going to negative infinity. Now, on the pre-calculus test, you'll see it written with limit, written up here, but that's not important. As long as you're able to match what's going on with those end behavior, that as x goes negative, p of x is going positive. As x goes positive, p of x is going negative. So that's all with that one. Okay, so here's another one where, oh, this does not work. We are asked to find, so we have x squared, no, it's minus, x squared minus 4x plus 3 over x squared minus 3x plus 2. And we are asked to find the x-intercept, the asymptote, and the whole for this one. So to find the x-intercept, it's when the numerator equals 0. So all we have to do is factor our numerator. So in factoring, we need a number that multiplies to give us positive 3, but adds to gives us negative 4. So that's negative 3 and negative 1. Negative 3 and negative 1 is positive 3, and negative 3 plus negative 1 is negative 4. So we have our x-intercept where x is equal to 3 and x is equal to 1. Because it's always the inverse, so we have x is equal to 3 and then x is equal to 1. All right, we also have, but then they ask us to find the vertical asymptote. So we would define a vertical asymptote. Now that's dealing with the denominator, so you have to factor out the denominator. So we need something that gives us positive 2 when we multiply, but negative 3 when we add. And that's negative 2 and negative 1. So our asymptote would be x equals 2 and x equals 1. But what we see here is that we can actually cancel these out. So if we cancel these out, so here we have our x-intercept. That's x equals 3. We've canceled out the x equals 1, but that actually is called our whole. So at x equals 1, that is a whole. That's important to still know. And then our vertical asymptote is at x equals 2. So being able to solve for these, you would be able to see all 3 of these information. And the last thing I want to show you is, they're talking about even and odd function. So this one is just something that's probably good to know. So an even function has symmetry about the y-axis. So if something is an even function, it'll be like this. So it's symmetrical about the y-axis. That's like, this is a parabola, x to the second power. It's symmetrical about the y-axis. Now, if something is an odd function, it's symmetrical about the origin. So this is the origin, so it might be something like this. So it's symmetrical about the origin. So imagine folding it along the origin, the two sides will match. So in this particular question, it says this is an odd function and it's symmetrical about, well, it just says it's an odd function. So you would need to know that it's symmetrical about the origin. So, and it says if this is equal to -4, which one would make it an odd function? What would be the function of -3? So if +3 is equal to -4, so it'll be like right here, then -3 would have to equal +4, because that would be what an odd function is. So if you see a table where, okay, well, if it's given to you in a table where you have -2 equals 3, but +2 also equals 3, well, that's an even function. You know, if that pattern continues. If you have a table, if you're given a table where you have -2 equals 3, but +2 equals -3, okay, so then that's an odd function. If you don't see any patterns like that, then it's neither. So that's when they ask you, is this even, odd, or neither? Well, that's how you can determine that, to see. You can also determine by looking at the graphic, and if they're symmetrical about the y-axis, it's even. If it's symmetrical about the origin, it is odd. All right, and that's all for today to help you prepare for AP Precalculus. I hope this was helpful. Remember to like and subscribe, and comment if you have any ideas on more videos. Bye.